Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to talk about how to find compositions of functions. And these particular functions include some that are rational, which means they look like fractions with polynomials in them. If you like the video, please give it a thumbs up. And if you'd like to see more of my videos, please subscribe to my channel. Let f of x equal square root of x minus 1, g of x equal 2 over x minus 3, and h of x equal 1 over x plus 1. We're supposed to write a formula for each composition. We have a part A, and down here we have a part B. Part A, we're going to find f composed with g composed with h. That's how you read those little circle notations there, composed with. But as soon as I see that notation, I rewrite it in regular old function notation. So we're going to have f of g of h of x. And there are many ways that you can approach the problem, but the way that I like to do it is to kind of think in terms of order of operations. What do we normally do? The innermost parentheses first. So I'm going to focus my attention on this guy here, h of x. And I'm literally going to replace h of x with what he's equal to. So we're going to have f of g of, and instead of writing h of x, I'm going to write 1 over x plus 1, because that's h of x. Okay, now I'm going to work my way outward. So I'm looking at g of 1 over x plus 1. So I need to know what the rule for the function g is. And we know that g of x is equal to 2 over x minus 3. So we're plugging 1 over x plus 1 into this function. This throws people off, I think, because there's an x in the g and there's an x in the expression we're plugging in. So think of this not as an x, but as a little empty box that we're going to fill up with whatever we're being told to package in that box. We're going to package that 1 over x plus 1 in there. So I'm going to have f of, and then instead of g of 1 over x plus 1, what it's equal to. G of 1 over x plus 1 would be 2 over 1 over x plus 1 minus 3. See how I put the 1 over x plus 1 in there instead of the box? So that's what I'm going to have over here. 2 over 1 over x plus 1 minus 3. Now, you could simplify at this point, but I'm going to choose to leave that for the end. So I'm just going to leave the expression as it's written. And I'm going to plug that whole thing into f. So what's the rule for f? F of x would be the square root of x minus 1. But of course, we're not putting an x into f. We're putting that whole big, crazy looking expression. So think of this as a little box. So if we're going to plug in, we have f of 2 over 1 over x plus 1 minus 3. That would be equal to the square root of all of that stuff and then minus 1. So that's what's going to go over here. The square root of 2 over 1 over x plus 1 minus 3 and then minus 1. Right, so technically this is the formula for the composition. But I often get questions from students on how to simplify an expression like that one. So let's take a look at how to simplify. So within this square root, we have what's called a complex rational expression. That means it's got fractions within fractions. As with most things in math, there are different ways you can approach the problem, but what I like to do is to multiply in this big complex fraction. I'm going to multiply it by 1 so it doesn't change the value of it, but I'm going to write the 1 as x plus 1 over x plus 1. I'm going to multiply that into the numerator and denominator of that big fraction. And the reason I chose the x plus 1 is because I'd really like to cancel this denominator here. So if you distribute the x plus 1 to each term in the denominator, if you multiply x plus 1 times its reciprocal, 1 over x plus 1, you just get 1. And then we have to multiply 3 times the x plus 1 as well. This was 1 because you have x plus 1 over x plus 1 when you distribute. I'm going to leave the numerator factor just in case something will cancel in a minute. But in the denominator, I'm going to distribute the negative 3. So I have 1 minus 3x minus 3. And so we're going to have the square root of 2 times x plus 1 over negative 3x minus 2. So I can say that f composed with g composed with h of x turns out to be the square root of 2x plus 2 over negative 3x minus 2. All right, now we're going to try one more. This is the same three functions, but the composition's in a different order. This time we're going to do g composed with h composed with f. As soon as I see the composition notation, I'm going to replace it with function notation. So we have g of h of f of x. Okay, I'm going to replace the f of x with what it's equal to, square root of x minus 1. This gives us g of h of square root of x minus 1. Now we're going to plug the square root of x minus 1 into the function h. Now h of something is going to be 1 over that something plus 1. So we're going to fill in the box. What are we filling in? Square root of x minus 1 goes into the box. So we have g of 1 over square root of x minus 1 plus 1. All right, now we need to plug all of that into g. And what does g do? G takes whatever you plug into it, and it puts it into 2 over that thing minus 3. So I'm going to have 2 over 1 over the square root of x minus 1 plus 1. That's the box part. And then we still have that minus 3 to tack on there. All right, so let's talk about how to simplify. This really is the composition of functions, but how do we simplify it? So again, we have a complex fraction, and again, we have a denominator in our little fraction inside of the bigger fraction. We want to clear that denominator. So I'm going to multiply on the top and the bottom of the big fraction by exactly what's in that denominator. So I'm really just multiplying by 1, so I'm not changing the value of the expression. In the denominator, then I have to distribute. This fraction bar is like invisible parentheses. So whatever I'm multiplying by here, I have to distribute to each term. So I'm multiplying, and when you multiply a whole number times a fraction, it goes into the numerator. So what I mean by that is down here, instead of a 1 in the numerator, I'm going to have square root x minus 1 plus 1 over square root x minus 1 plus 1. This is the reason why I'm doing this, because you can see that's going to cancel. And then we have minus 3 times square root of x minus 1 plus 1. And in the numerator also of the big fraction, we have square root of x minus 1 plus 1 as well. That's kind of the key step for the simplifying. So you can see this is going to leave just a 1 here. So we have 2 square roots of x minus 1 plus 1 over, plus 2 rather, because I got to distribute the 2. And down here we have 1 minus 3 square roots of x minus 1 minus 3. Combining like terms, the 1 and the negative 3, we get 2 square roots x minus 1 plus 2 over negative 2 minus 3 square roots of x minus 1. And there may be other ways to write it, but at least we've gotten rid of that complex fraction. We never like those, so we're done. So that means that g composed with h composed with f, written as a function, is 2 square roots x minus 1 plus 2 over negative 2 minus 3 square roots of x minus 1. And don't make the mistake of thinking that the 2's will cancel, because you can only cancel factors, not terms. And these don't have any, the numerator and denominator don't have any common factors. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.